Hello everyone, welcome back to my channel, That Model Railway Guy, and welcome to a tutorial video today all about wiring up points, specifically the new Unifrog points. Now, before we go any further, I do just want to say a big thank you to the Model Centre who have very kindly sponsored this video. More about them later on though, because we have a lot of talking points to cover today. See what I did there? Because we're talking about points and... yeah, okay, never mind. So, for the past few decades, there have really only been two main types of points, Insulfrog and Electrofrog. Now, don't worry if you don't understand what that means, I'm going to explain it all in just a moment, and that's really only where the story starts. But hopefully, by the end of this video, you'll understand how Unifrog points fit into the mix, as well as understanding how to wire them up for operation on your model railway. So, let's dive in. So before we jump in with how the new Unifrog points work, I feel like it's a good idea to first set out the differences between the existing Insulfrog and Electrofrog points. This will help us better understand what problems the new Unifrog points are trying to solve. Starting off with Insulfrog points, you can identify these by the plastic frog, which is this part here. Because this part of the rail is plastic, it's insulated and doesn't conduct electricity, and there's a very good reason for that. On this diagram you can see we have our positive and negative rails. When the blades on the point touch the corresponding rails, the power flows up the blade towards the frog. The issue here though is that we have both polarities crossing each other, and that causes a short circuit. So the easy solution is to make the frog itself plastic to prevent this. Another advantage to Insulfrog points as well is that when they're switched to the main line, the power is automatically cut to the diverging route. And when the points are set in the opposite direction, the power is cut to the main line. This is really handy for beginners on analog control who might want to leave a loco in a siding without it reacting to the controller while running locos elsewhere. Of course, for DCC you might want to have the siding be live all the time, but you can remedy this by using track clips on the point to provide constant power. Personally though, my preferred method is to have feeder wires from your main power bus connected to the siding itself, providing a more reliable source of power. Insulfrog points are generally what most beginners start out with, since they're both very easy to use and are often what you get in a starter set. But they're not just for beginners. In fact, I used them on my exhibition layout because I like how easy they are to use. The biggest disadvantage to Insulfrog points though is that by having a dead section of rail, it might cause the locos to stall. That isn't a guarantee of course, and you could always rectify that by adding a stair live, but it is still a consideration, and that's where Electrofrog points come in. The biggest difference with these is that we have a metal frog to allow for consistent power to our locos. But if you remember from before, that causes a short circuit, right? Well, not in this instance, because the Electrofrog points switch the polarity of the entire section. However, we do then potentially get a short circuit beyond the point if you have more power feeds further down the line. So usually this requires insulated fish plates after the point to prevent this, and if you're using analog control you might require switches to turn power on or off to each section. Electrofrog points are a little bit more complex and there's a lot of different ways to use them. I could probably do a whole video on these alone, but it's this added complexity that the new Unifrog points are trying to resolve while still maintaining some of the advantages. So initially a Unifrog point looks pretty similar to the Electrofrogs with that metal V. However, look closely and you'll notice that there are tiny breaks in each of the rails around it. This means that straight out of the box, our Unifrog point actually acts like an Insulfrog point. Even though the frog is metal, it's completely isolated from any power. The main difference between Insulfrog and Unifrog is that the line beyond the point doesn't get isolated either, those are live all the time. That could be an issue for those on analog control, but on DCC it's less of a problem. The clever thing with Unifrog points though is that the isolated metal frog actually has a wire connected to it. We can use this to provide power to the frog alone, which we can switch to match the polarity that we need depending on the position of the blades. This is often what people would do with Electrofrog points, where they'd switch the polarity of the entire section, but now we can isolate it to just the frog. Now you could just wire this up to a toggle switch, but then you have to remember to not only change your points but also your polarity switch as well, and if you've got a lot of points on your layout, that could get confusing quite quickly. Ideally, we want the polarity to switch automatically when the point is changed, and luckily that's what I'm going to show you now. This process does all start with how you actually lay the point, so I'm going to take you through the entire process from start to finish. In this instance, I'm using Peco's TT120 Unifrog Points, but it's the same basic process regardless of what scale you're using. First, you'll want to figure out the position you want your point to be. You can then mark where the tie bar is with the little hole that interfaces with a motor. On the TT points, this is on the side, which I believe is the same for N gauge and 009 points too. However, for 00 gauge points, usually the hole is in the middle of the tie bar. It's now time to drill the relevant holes. For the motor, generally I find a 5mm hole is plenty. You also need to drill a smaller hole for the feeder wire. This doesn't need to be as exact though, as it's only to allow the frog feed wire to pass through the baseboard. Usually I use a 2mm drill bit for this. It's now time to lay the point using whatever method you like. I'm using double-sided tape here, but that isn't a requirement. You can use glue or track tacks or however you've laid the rest of the track on your layout. First though, you do need to make sure you push the frog feed wire through the hole you just made. You can then lay the point as normal, just making sure that the hole in the tie bar is over the hole in the baseboard for the motor. With the track connected up around it, this point is now functioning in a similar manner to an Insulfrog point. Obviously though, we want to motorize it and use the motor to power the frog too, so this is where things start to get a bit more interesting. So before we carry on, I do just want to say a really big thank you to the Model Centre for sponsoring this video today. TMC are one of the biggest model railway retailers in the country, selling all of the main scales and gauges and quite a few of the more niche ones too. And of course, since we're talking about track and points today, it would seem silly not to mention that TMC have a huge stock of Peco track. All of the track and points on the TT layout I'm currently building, well, that was all bought from the Model Centre. They stock Insulfrog, Electrofrog and also the new Unifrog Points too. So if after seeing this video today you fancy trying them out yourself, well, you can get hold of them from TMC on their website, themodelcentre.com. It's well worth a look at everything they do, and from personal experience I can highly recommend them. So yeah, thank you so much to TMC for sponsoring this video, and now back to the tutorial. For the point motors, I'm using SEEP PM1s. They do specifically need to be the PM1s or the PM4s, as these both have the auxiliary switch that we'll be using to control the polarity. You can use more expensive point motors if you like, but these are both very cheap, very simple and very easy to get up and running. The motors have a screw hole at each end to attach them to the underside of your baseboard, so I like to mark these positions using a pencil. With the motor removed, I then just drill a pilot hole for the screw. Then with the motor back in position, I screw it all in place. And when you do this, you'll want to make sure the rod is interfacing with the tie bar on the point. On top of the baseboard, you can see we have the excess rod sticking up through the hole, so I'll trim this down using a Dremel, which makes short work of the process. The motor is installed, but so far it's not actually connected to any power. You can see we've got lots of solder tabs here, but before we start wiring up, let's take a moment to discuss exactly what we'll be doing. So if you'll indulge me once again, we have another diagram, this time featuring our point motor. Now initially we'll wire this up just like a normal point motor. That means tab A is the wire from one side of our toggle switch and tab B is from the opposite side. Tab C is then our common return, and if you have multiple points you can daisy chain this wire to each one. These three wires will allow you to switch the point blades back and forth. Obviously though, you need to take into account how you're powering all this, what switches you're using, whether you have a CDU in the chain as well, but that's all stuff I've covered in previous videos. To switch the polarity of the frog, we have three solder tabs left. Tab D will be one side of our track power, and tab E will be the opposite side. Obviously here I've shown these as connected to the rails, but in reality this could actually come directly from your power bus, especially if you're using DCC. Finally, the frog feed wire goes to tab F. This means that when the motor switches back and forth, it'll make contact with either D or E. That power will then be sent through to F, which will power the frog. Because the frog is isolated from everything else, we don't need to worry about short circuits, as long as you get the power feeds for D and E the right way round. So that's the plan, now we just have to do it for real. Obviously this is going to require some soldering, which I know does scare some people. To be honest though, I'm pretty terrible at it and I've managed, so I'm sure you can give it a go. I like to start off though by adding a quick blob of solder to each tab, which really helps when joining the wires. As on the diagram, I'll start off by soldering one side of our switch to tab A. And then the opposite side of the switch is soldered to tab B. Then my common wire is connected to tab C. As I mentioned before, this can be daisy chained between several point motors rather than needing a separate wire for each one. The track feeds are then connected to D and E respectively. The most important thing here is to make sure you get the correct polarity for each side, and that will depend on how the motor is orientated. If the worst comes to the worst though, it's a 50-50 chance, so you just unsolder the wires and then swap them round. You can see further along we have the frog feed wire poking through the baseboard from before. Annoyingly, this wire isn't long enough to reach the motor itself, so I'll have to solder on an extension. This may well be by design though, since it is a bare piece of wire. This final wire can then be soldered to tab F on the motor, and that is the entire process. You can then repeat this for your other points on the layout. Obviously, when you've got several points that you're powering in this fashion, it does create a lot of wires, so it's a good idea to get some cable clips to tidy everything up. Also, you'll notice I've kept my color coordination consistent across the entire layout, which will really help if there's ever a problem or something comes loose. Although this does look a bit crazy, the key thing to remember here is that it's just the same 6 wires repeated multiple times, and I find if you tackle each one individually, it's not actually as complex as it looks. Anyway, that's the entire process of wiring up Unifrog points, and as you can see here, the Class 08 is having no trouble over these despite its short wheelbase. I do hope you found this video useful, especially if you're looking into Unifrogs for a future layout, and don't forget to subscribe to the channel if you want to see more tutorials and model railway content like this. That's it for today though everyone, thank you so much for watching and I'll see you in the next video. Bye!